Assalamualaikum, hi everyone. So this is a video for chapter 6, benzene and its derivative. In this video, we're going to discuss subtopic 6.2, nomenclature of benzene and its derivative. So, at the end of this lesson, you should be able to first draw structures and name benzene derivative according to the IUPAC nomenclature for first monosubstituted benzene, disubstituted benzene, tri and tetrasubstituted benzene, and lastly, apply the IUPAC rules to name the compounds with C6H5 as phenyl or C6H5CH3 as benzyl, which is a substituent. So now, let's start. So, nomenclature of benzene and its derivative. The first one, we're going to look on the monosubstituted benzene. So as you know, your benzene ring will look like this. Okay, so this is your benzene ring. So basically, it looks like a cyclohexane. It's just that it will have 3 alternating double bonds. So monosubstituted meaning we are substituting one of the hydrogen bonds, the carbon hydrogen bonds over here. We're going to substitute with something else. Okay, and then we're going to name that benzene. So now let's take a look. For monosubstituted with one substituent benzene, first we're going to name the substituent and then add the word benzene. Okay, so for example, this structure. So we have a benzene over here, the aromatic ring. One hydrogen is substituted with fluorine. So the name of this compound will be fluorobenzene. Okay, so fluoro in front to show that it is from the halogen group. Okay, and then benzene to show our aromatic ring over here, our benzene ring. Okay, next. Okay, here you have NO2. So NO2 as a substituent or as a functional group, we call it as nitro. So nitrobenzene. Okay, next. Okay, here we have our alkyl group. So our alkyl group over here, we have 1, 2. So 2 carbon alkyl group. So this is our ethyl. Thus, the name of this compound, it will be ethyl benzene. And when naming the substituted benzene over here, okay, the L and the B, it must be close together. In other words, it will be one word only over here. Okay, because there is no numbering for this one, because we only substitute one hydrogen with another substituent. Okay, so that's why you don't have to number it. Okay, so note, the structure of benzene can also be drawn as this structure. So this is your resonance hybrid structure. So it's either you draw your benzene with alternating 3 double bonds over here, or you can draw your benzene with a circular ring over here to show that it is the resonance hybrid structure. Both are accepted. Okay, next. IUPAC rules allow some common names to retain. The common names over here, which does not present benzene. Okay, the word benzene is not in this structure. Okay, it's just a common name, but it is accepted by the IUPAC. So for example, okay, when we have a benzene ring, okay, and then substituent over here is methyl, so the IUPAC name will be methyl benzene. Okay, but the common name for methyl benzene is toluene. So you need to make sure that you know this name, because this is the common name that is also accepted by IUPAC. Okay, next. Okay, a benzene ring. Okay, attached to a hydroxyl group over here. Okay, so the IUPAC name, okay, will be hydroxybenzene, and the common name for this structure, we call it as phenol. Benzene ring with hydroxyl group. Okay, next, aniline. Aniline is a benzene ring that is attached to an amino group over here, NH2. So that's why the IUPAC name will be aminobenzene, but the common name, we call it as aniline. Okay, next one. Benzene ring with a carboxyl group over here, COOH, or sometimes also written as C-double-bond-O-OH. Okay, it's the same thing. So it's your carboxylic acid. So for this one, we call it as benzoic acid. So for this structure, there is no IUPAC name. So the name benzoic acid is accepted by IUPAC as the general name. Okay, the general name and also its common name. Okay, next, this one. Okay, CHO over here. Okay, so a benzene bonded to CHO. CHO here means it's C-double-bond-OH. So you have a carbonyl group that corresponds to an aldehyde. So we call this structure a benzene bonded to a carbonyl group with H and aldehyde as benzaldehyde. And then lastly, okay, a benzene ring, okay, an aromatic ring over here, bonded to C-double-bond-O, a methyl group, a carbonyl group over here, and one alkyl group, a methyl group over here. So carbonyl group bonded to 2 carbon, it's a ketone. So this structure, we call it as acetophenone. Okay, so you need to make sure that you memorize the name and also the structure. Okay, what name do I meant here? The common name: toluene, phenol, aniline, benzoic acid, benzaldehyde, and also acetophenone. Okay, because sometimes in exam, instead of giving the name hydroxybenzene, okay, the question will call this structure as phenol. So you need to make sure that you know which one is phenol. Now, let's move on to the next one. We're going to look at disubstituted benzene. So for this disubstituted benzene, we're going to look on 2 different examples. The first one, we're going to look at disubstituted benzene with 2 same substituents. So how are we going to name a benzene that has 2 same substituents? So relative position of substituent are indicated by prefix. Okay, we're going to use ortho, meta, para. Okay, or we can also label it as O, M, and P, or by the use of numbers. So you have 2 options over here. Okay, so what do I mean by here? So when I talk about the ortho position, meaning the 2 substituent is located at carbon number 1, and then the other one is at carbon number 2. Okay, and then if meta is at carbon number 1 and then carbon number 3. And lastly, para, one substituent is at carbon number 1 and the other one substituent is at carbon number 2. Okay, so let's look at one example. Okay, so we have over here a benzene ring that is bonded to 2 bromine. Okay, so we have 2 bromide over here. Okay, and then, so these are the substituents, the same substituent. So how are we going to number? So you're going to number by giving the substituent the lowest possible number. Okay, so just put, okay, example, this bromine as number 1, followed by this one as number 2. Okay, we don't go the other way around. Okay, because if we go anti-clockwise over here, this bromine will become number 6. So that's why we go clockwise, so that this bromine will become number 2. Okay, so how do we name? Okay, so if we use numbering, okay, the name will be 1,2-dibromobenzene. It's a benzene with 2 bromine, so dibromo at carbon number 1 and carbon number 2. Okay, so besides 1,2-dibromobenzene, we can also call it as ortho-dibromobenzene. So the ortho position, the O over here, it shows the position 1 and 2. So the bromine here at carbon number 1, this bromine at carbon number 2. And to write it down, okay, we will separate the alphabet O with D, with and hyphen over here. Okay, it's not comma, okay, even though it's both are alphabets, but ortho over here it shows numbers, so that's why we put an hyphen over here. Okay, next one. I still have 2 bromine attached to the benzene ring, okay, but at a different position. So this is our bromine. So we have dibromo over here. So let's put the number. Okay, so I let this bromine, this carbon bonded to bromine as carbon number 1. Okay, and then this carbon bonded to this bromine is carbon number 4. So as we name this one, so it will be 1,4-dibromobenzene, or if you look at 1,4 position, it's for the para position, para half, okay, half of our benzene ring. So you can write it down as P-dibromobenzene. And then lastly, I have another structure over here. So I still have 2 bromide, so I have dibromo over here. And then let's put the number. So if you look over here, the substituent, bromine at carbon number 1 and then at carbon number 3. So diupac name 1,3-dibromobenzene if we use numbers, or 1,3 represent the meta position. So it will be meta-dibromobenzene. So M-dibromobenzene. Okay, so this is how we name a disubstituted benzene with 2 same substituent. So this one is easier because we don't have to prioritize the position of the substituent. Why? The substituents are the same. Okay, so we can start at any substituent as long as the final name will give you the lowest combination. Okay, now, so let's look at the next one. Okay, we're going to look at disubstituted benzene, but with 2 different substituents. Okay, we can still use the auto, para, and meta now, or we can use numbering, but for 2 different substituents, we need to alphabetize the names of substituents preceding the word benzene. Okay, so what do I mean here? So for example, over here, I have chlorine and I have bromine. So we still need to give these 2 substituents the lowest possible number. Okay, but which substituent are we going to give? Carbon number 1 and carbon number 2. It's next to next. Okay, it's next to each other, so it will be 1 and 2. But is chlorine 1 or is bromine 1? So we're going to put the numbering based on alphabet. So B will come first, so that's why bromine will be numbered as 1 and chlorine as number 2. So it will go anti-clockwise. So the name will be, either you put ortho-bromochlorobenzene, okay, because it's at carbon number 1 and carbon number 2. So it's a combination for ortho position. So for this one, since there is no numbering present, so you need to put bromo, chloro, and benzene in one word, close to each other. Okay, there's no spaces between bromo and also bromochloro and chlorobenzene. So it's one word like this. Or you can just simply write down like this. So if you were to put the numbering, so it will be like this. It will be 1 and hyphen bromo and hyphen 2 and hyphen chlorobenzene. So 1 bromo, 2 chlorobenzene, like we used to do. Okay, so let's look at another one. So over here, okay, we have nitro group, and chloro. So between N and C, okay, C will come first. So that's why we're going to put chlorine as carbon number 1. And then we're going to go anti-clockwise so that our nitro group over here will get a lowest number possible. So it will get number 3. So a 1-3 combination will give us a meta position. Okay, so the name, you will write down chloro first based on alphabet. So meta, chloro, nitrobenzene. Or you can just simply use number. It will be 1 chloro. Okay, here it's not 2, it's actually 3 nitrobenzene. Okay, so 1 chloro, 3 nitrobenzene. Okay, so this is the first one. Okay, next. For disubstituted, two different substituents, select one of the substituent that give new parent name and numbered as carbon 1. So remember the previous slide just now where we have for the monosubstituted one substituent. For the second one where we have a common name for our benzene with a substituent. Example, toluene, phenol, aniline, benzoic acid, benzaldehyde, and acetophenone. Okay, that particular name can be the parent name because it's a benzene with a functional group. Okay, so what do I mean actually by this? So for example over here, okay, I have a benzene ring bonded to a carboxyl group. Okay, so the structure, the whole structure over here, this will be our parent. Okay, so if you have a benzene with a carboxyl group, what do we actually have? We have a benzoic acid. So automatically, the carbon bonded to the carboxyl group, we will give it as carbon number 1. Okay, so it will be, this is 1, this is 2. So the nitro group over here will be substituent. So now, instead the parent name is benzene, we're going to change the parent name. Okay, so it will be 2-nitrobenzoic acid. Okay, if we use number, or since it's 1 and 2 position, ortho-nitrobenzoic acid. Okay, so I give you another example. Okay, so over here, we have a benzene, okay, with alkyl group over here. Okay, so this is one of the benzene that have a common name. So this will be your parent. Okay, a benzene that is attached to a methyl group, we call it as toluene. Okay, so automatically over here, we will give this carbon as carbon number 1 and the chlorine at the third position. So you will have a meta, okay, position over here. So you can name this structure, okay, as 3-chlorotoluene if we were to use a number. So 3-chlorotoluene, toluene because we have a benzene ring bonded to a methyl group, or metachlorotoluene to show the position is 1 and 3. Okay, 1 is for the methyl group, 3 is for the chlorine over here. So in other words, what we have discussed just now, carbon atom bearing the substituent that define the new parent name is numbered as carbon number 1. And we're going to do this based on priority. So if you look over here, we have two different functional groups. We have over here a hydroxyl group and down here a nitro group. Okay, now, so which parent name we will give? You will have, if benzene bonded to hydroxyl group, okay, if I were to, okay, if this one, okay, we will have phenol. And then, if it's this one, we will have aniline. So, which parent name will we choose? So, we're going to choose the parent name based on the priority over here. Okay, so this is the priority of the main group. So, the highest priority will be given to the carboxylic acid. Carboxylic acid means it has the functional group carboxyl COOH, ester COC, aldehyde C double bond OH, ketone C double bond O bonded to methyl group, alcohol carbon bonded to hydroxyl group, amine, okay, H2, alkenes carbon-carbon double bond, And lastly is our alkanes and halides. So halides over here is basically your haloalkane. Okay, so we're going to choose based on this priority. Okay, so based on this list of priority, okay, hydroxyl group, which is our alcohol over here, okay, is higher, has higher priority than amine. Okay, so that's why the name of this structure, we will give it as, okay, the parent name will be given to phenol. Okay, and the NH2 over there will be the substituent. Okay, so NH2 as a substituent, we're going to call it as amino. Okay, and then our parent over here is phenol. So automatically, the carbon that has the hydroxyl group will be carbon number 1. Okay, and then 1, 2, 3, 4. So we have a combination of 1 and 4. So we have a para substituent. So we're going to name this as, okay, so let me erase this first. Okay, so the name will be 4-aminophenol or para-aminophenol. So like I mentioned before, here our NH2 as a substituent, okay, we call it as amino. Now moving on to the tri and tetrasubstituted benzene. So before I proceed with this one, I just want to remind you, for the auto, meta and para position, it can only be used for 2 substituted benzene. Okay, so if you have 3 or 4 or more than 4, you cannot use the auto, meta and para naming. Okay, so now let's take a look. So for the tri and tetra substituted 3 or more substituent. Okay, so for the first one, for the same set of substituent, assign the lowest set of numbers. So for example, I have on the benzene ring 3 bromine. Okay, 3 bromine over here. So we're going to number the ring based on which will give us the lowest possible substituent. So over here, we don't have any new parent name. So the parent will be benzene. Okay, so the numbering, okay, so 3 bromide, so we have tribromo over here. And the numbering, okay, this carbon will be carbon number 1. 1, 2, 3, and 4. So we have a combination of 1, 2, and 4. So we're going to name this benzene as 1, 2, 4 tribromo benzene. So assign the lowest sets of number. Okay, but if let's say we have a different set of substituent, okay, so alphabetize the substituent names. So for example, over here, okay, so chlorine, bromine, and iodine, all are halogens. Okay, so since all are halogens, our parent name will be benzene. Okay, and then we're going to put carbon number 1. Okay, by right, if based on alphabet, we're going to give bromine as number 1, but we still need the lowest possible numbers. Okay, the lowest possible combination of numbers. So that's why for this one, okay, we're going to give carbon number 1 to chloro instead of iodine, because C came first and then I. So that's why the name for this one will be 2 bromo, 1 chloro, 3 iodo benzene. Okay, now let's look at another example. This one. Okay, so we have chlorine, we have an alkyl group over here, but our alkyl group is ethyl and propyl. So we don't have a new parent name over here. As you know, okay, a benzene ring with a methyl group has a new parent name, toluene, but we don't have toluene over here. Okay, so this is the parent, still benzene. Okay, we have over here ethyl, this is propyl, okay, and then this is chloro. Okay, so we're going to number based on the alphabetical order. So based on alphabetical order, by right, it should go to chlorine. Okay, but if we put chlorine as number 1, okay, the set of numbers will become bigger. Okay, so instead, we give ethyl as number 1. So that's why it will be 1, 2, 3, and 4. So the name will be 4-chloro, 1-ethyl, and 2-propyl-benzene. Now, we're going to look benzene as a substituent. Okay, so what does it mean, a benzene as a substituent? Okay, first we have a phenyl group. So, a benzene ring as a substituent, we call it as the phenyl group. So, meaning, if you look over here, so this is the parent chain. Okay, the parent chain must have a longer number of carbon compared to our benzene over here, or the parent chain should have a functional group. So, our benzene, okay, directly bonded to the parent chain will become a substituent, and we call this substituent as phenyl. Okay, so phenyl is C6H5, and then sometimes in the structure, in the molecule, we put it as pH over here. Okay, now let's look at another one. So another one, we have a benzyl group. Okay, so a benzyl group is C6H5 and CH2. Okay, so how does it shows over here? Okay, so for example, okay, this one is the parent chain. Okay, and the parent chain is bonded to one carbon and then bonded to the benzene ring. So the whole structure over here, we call it as the benzyl group. Okay, so for example, okay, I give you this. Okay, so by right, this structure, okay, we have a functional group of chlorine over here. So we will have a methyl chloride. Okay. So for this one, the name will be chloromethylbenzene or a benzyl chloride. So why is it chloromethylbenzene? So benzene is the parent. Okay. Chlorine is substituted on the methyl group. This methyl group is a substituent to the benzene. So that's why chloromethylbenzene. Or we can just simply put as a benzyl chloride. So meaning, okay, this, the whole thing over here, this is your benzyl. Okay, and then this is your chloride. So if alkyl substituent is larger than the ring, more than 6 carbon, the compound is named as phenyl substituted alkane. So for example here, we have a 7 carbon chain, okay, and then we have a benzene ring. So like I mentioned before, when you have a longer number of carbon than the benzene, so this will be the parent name. Okay, so this substance, the name will be 2-phenyl-heptane because at this carbon is directly bonded to the benzene ring, so it's phenyl. Okay. If the chain is unsaturated, have carbon-carbon double bond or carbon-carbon triple bond, or contains important functional group, the benzene ring is considered as a phenyl substituent. Okay, so for example, here, even though you only have 4 carbon, but you have carbon-carbon double bond over here, so the benzene will become a substituent. Okay, so this will be the parent chain. So we have a butene over here. So the name will be 1-phenyl-2-butane. Or another example, okay, we have a straight chain over here that contains a hydroxyl group. So the priority is higher. So even though it has 2 carbon, it becomes our our ethanol. Okay, and then this benzene will be a substituent, so we call it as phenyl. So the name will be 2-phenyl ethanol. Okay, so that's all for the naming. So I see you guys on the next video. Thank you.